There's a famous video you can search for on YouTube about Harvard graduates trying to explain what causes the Earth's seasons. Well, when you get to Harvard on graduation day and you answer that question for the next video, after this you're going to understand why we have seasons. You should have printed out a map that looks very similar to what you see there on the screen. It's a map of the Earth with a bunch of those lines labeled. The one in the center, of course, is called the equator. Now, that is the 0-degree line of latitude, and that is a monument in Indonesia to the equator. Equator starts with the letters E, Q, U, and that line indicates the spots on the Earth, all the spots on the Earth that are equal distance from both poles. That's our 0-degree line of latitude. As you move away from that equator, north or south, the numbers will increase at an angle until we get to the angle of 90 degrees. 90 degrees north is the North Pole, 90 degrees south is the South Pole. In this part of Pennsylvania, we actually live right next to the 40th parallel. There's actually a sign for it just 3 miles south of Columbia, right here on River Road. About 23.5 degrees north or south of the equator are the lines of the tropics. The north one is called the Tropic of Cancer. The reason why it's called the Tropic of Cancer has to do with the zodiac. If your birthday's in the zodiac month of Cancer and your sign is Cancer, your birthday's probably the end of June or sometime in July. Well, the first day of the month of Cancer is the day that the sun's rays are shining on the Tropic of Cancer. The first day of Cancer is June 20th. That is also the first day of our astronomical summer. To the south of the equator, we have the Tropic of Capricorn. Capricorn also a zodiac sign, and the sun's direct rays shine on that line on December 20th, the first day of astronomical winter. There's a monument to the Tropic of Capricorn in Australia and the Tropic of Cancer in Thailand. The two northernmost and southernmost lines are the Arctic lines. The north one is called the Arctic Circle. The south one is called the Antarctic Circle. The word Arctic comes from the word Arctos, which means bears. And that's a monument in Norway to the Arctic Circle. And the bear they're talking about isn't a polar bear, though that would make a lot of sense. There are polar bears up north and there are no polar bears in the south. But they're referring to this bear here. We call it the Big Dipper, but it's the constellation Ursa Major, the Great Bear. So in the Arctic Circle, the Great Bear is in the sky, and in the Antarctic Circle, it is not in the sky at night. Now, the Earth is very complicated as far as its motions are concerned. It has this motion called rotation. That's the spinning of the Earth, and it causes day and night. So here's my friend, the globe, and we simply spin it like this, and this is rotation. You see the bright spot from the light shining here. Places on this side are in the light. Places on the reverse side are in the dark. Now, even though we've known for years and years that the Earth spins and it causes rotation, it wasn't until 2003 that we had photographic evidence of that happening. We sent a robot to space called the Mercury Messenger. And on its way to Mercury, in order to gain a little speed and to get its orbit around Mercury, it flew by the Earth. And for the first time ever, they put an HD camera on the space probe to take pictures as it approached Earth and to photograph this movie right here as it pulled away. And you will see the rotation of the Earth as it pulls away from our planet. So there's our round Earth physically rotating. That's what's causing day and night. You see the parts there in sunlight and day, and the other parts are in the night. Pretty cool picture. Now, the Earth not only spins on its axis, it is also very rapidly moving around the sun. That is known as a revolution, and this in part is what causes our seasons. Our seasons are caused by the Earth's revolution. It has nothing to do with the distance the Earth is from the sun. The sun is not at the center of the Earth's orbit. It's offset by a little bit. We go around the sun in an ellipse. And in fact, there are times when we are closer to the sun than others. But in our month of January in the north, we are actually closer to the sun than the month of July. So it makes no sense that we would have our warmest month be when we're the farthest from the sun and the coldest month be when we're closest to the sun. So it has nothing to do with the distance from the sun that we are. It has everything to do with the fact that our Earth is tilted. And it's the orientation of that tilt that determines how focused the sunlight is on any single part of the Earth. If you take a flashlight and shine it directly on a flat surface, you're going to get a very focused beam. Where if you tilt the flashlight, you're going to spread that light out and it's going to be weaker. If you've ever played with a magnifying glass trying to burn leaves, you know this is true. When you focus the sunlight, you can get enough energy from the sun to make that focused beam very, very hot. And that's what happens in our summer. The direct rays of the sun are shining on the Tropic of Cancer. Therefore, the warmest weather is at the Tropic of Cancer in the northern hemisphere. And those that live closest to the Tropic of Cancer are going to be warmer. The farther away you are from that main heat source, the cooler the temperature is going to be. Now, the tilt of the Earth is always going to be pointed the same direction in space. So as I walk around this table, note that the axis of the Earth is pointed that direction. And as the Earth moves around a central point in space, the axis continues to point in that one direction. Because of this, during its path around the sun, different special lines on the Earth get the most focused rays at different times of the year. On the first day of summer, which is this picture over here, the summer solstice, the direct rays of the sun are on the northern hemisphere. On the first day of fall, the direct rays of the sun are on the equator. And on the first day of our winter, we are farthest from the most direct rays of the sun as they fall on the Tropic of Capricorn. These special lines that you have on your map of the Earth at the start of class mark where those direct rays fall. Let's take a look at an actual example of this happening. It starts here in December, where the direct rays from the sun are shining on the Tropic of Capricorn. The warmest air is down in South America, pretty far from here. As the Earth continues around the sun, we get to the vernal equinox. The sun's rays are shining directly on the equator, equal day and equal night for 12 hours. This is the start of spring. As we keep going around the sun, now we get to the summer solstice. The sun's rays are shining on the Tropic of Cancer. Here in Pennsylvania, we're closest to the most direct rays, which is down south of Florida. Therefore, it's the beginning of our summer. And finally, we loop all the way around to the autumnal equinox, where the direct rays again are on the equator. And as the direct rays move back to the southern hemisphere, we progress into winter. So here's another graphic that says basically the same thing. On the winter solstice, the direct rays are shining on the Tropic of Capricorn. On either equinox, they're on the equator. And in the summer solstice, the first day of summer, the rays are shining on the Tropic of Cancer. Now, if we take a look at a satellite observation of where the warmest surface is in the month of January, this is what we get. Notice it is through South America, through the middle part of Africa, and Australia is very, very warm. Now, as we shift to July, you're going to see the red lines in the center shift to the north, while the south, around Antarctica, it's going to get colder. It goes from blue to purple. Okay? Notice the difference. That's July, northern Africa, the Middle East. They're the warmest spots on the Earth, southern United States. If we go back to January, that line shifts south. All throughout the year, the direct rays and the warmth is floating between the two lines of the Tropic of Capricorn and the Tropic of Cancer. So let's take a look another way at this same thing that's happening. On the equinox is the day where the direct rays hit the equator, EQU. This happens on the vernal equinox, the first day of spring, and the autumnal equinox, the first day for our fall. This is the day where everyone on Earth gets 12 hours of sunlight. Hey, equal day and equal night, therefore the equinox. In fact, every day on the equator has equal day and equal night, 12 hours of day, 12 hours of night. Now, as we go from March into the month of June, the direct rays of the sun will shift northward until they get to the northernmost point, the Tropic of Cancer. This is called the summer solstice. This is the longest day of the year in the northern hemisphere. At the same time, the Arctic Circle, that special line that we haven't talked about yet, every point above that line experiences 24 hours of sunlight. The sun never sets there. On the other side of the equation, if you live below the Antarctic Circle, you are in total darkness at that time of year, and therefore it's going to be very cold. After we pass the summer solstice, the rays of the sun, the direct rays, will go back to the equator, and eventually, in around December 20th, 21st, they will shine directly on the Tropic of Capricorn. That is the winter solstice, the first day of the winter season and the shortest day of the year in the northern hemisphere where we live in Pennsylvania. At the same time, the Antarctic Circle now is experiencing 24 hours of daylight, and the Arctic Circle is experiencing 24 hours of darkness. Let's look at this a different way. If you were standing on the North Pole, you'll see this image right here. On the first day of summer, the sun will be in the sky all the time, going around you in a circle. That's right, it starts on the first day of spring when the sun just peaks up above the horizon. What it will do is it will go around the horizon all the way in a circle, very slowly spiraling up until it gets to that longest day of the year when it's at its highest point in the sky. And then it will start to shift southward until we get to the autumnal equinox. After that, it then disappears below the horizon for 6 months. Come a little bit farther south, though, and now these circles that were going around your head are now tilted at an angle of 66 degrees to the perpendicular. And notice on the first day of the summer solstice in June, you see the full circle there. The sun goes up in the sky, and it just looks like it's about to set before it returns back up into the sky again. On the day of the equinox, you only see half of a circle. The sun's up for 12 hours. And then on the winter solstice, it just peeks its head above the horizon for seconds. Someone actually went to Alaska and recorded this happening. They took a time-lapse photograph of every half hour as the sun approached the horizon, and this is what they saw. The sun looked like it was about to set and then went right back up in the sky. Now, where we live, it's not that extreme. We're around 40 degrees in the middle latitudes north. This is what it looks like for us. Notice in June we see more of that circle. Therefore, the sun's up longer than 12 hours. In December, on the equinox, it's up, rises in the east, and sets in the west 12 hours later. Then in the wintertime, we have a smaller circle in the sky. That means we have less than 12 hours of daylight. On the Tropic of Cancer, that's where the sun is going to be directly over your head on the first day of summer. You obviously have a little bit more than a half circle there, so you have a pretty long day. On the equinox, it rises in the east just like everywhere else and sets in the west, and you have 12 hours of sunlight. Whereas in the winter, it's a smaller circle. Now on the equator, take a look at this. All half circles. Every single day is exactly 12 hours long as the sun goes through the sky. It's just where it rises and sets is a little bit different as we move throughout the year. So I've said it one way. Here's a professional NASA scientist explaining it another way.
The seasons are caused by the Earth being tilted on its axis as it revolves around the sun. During the summer, the northern hemisphere is tilted toward the sun. Longer days and more direct sunlight produce warm summer weather. We can see in the lower figure that at 40 degrees north latitude on June the 21st, called the summer solstice, the sun rises in the northeast, reaches its highest position at noon, then sets in the northwest. On each successive day past the summer solstice, the noon sun is a little lower in the sky and daylight hours are a bit shorter. On September the 22nd, the autumnal equinox, days and nights are of equal length as the sun rises in the east and sets in the west. On December the 21st, called the winter solstice, the northern hemisphere is tilted away from the sun. This marks the day with the shortest daylight hours in the northern hemisphere. Shorter days and the lowest noon sun of the entire year produce cold winter weather. On each day past the winter solstice, daylight hours increase and the noon sun is a bit higher in the sky. On March the 20th, the vernal equinox, days and nights are of equal length. And in another 3 months, once again, it's summer as the northern hemisphere is tilted toward the sun.
So the Earth being tilted and the fact that it moves around the sun causes the sun to hit the Earth in different places. The sun heats the Earth. The most direct rays heat it the most. So that begs this question. June 21st is not the hottest day of the year here in Pennsylvania. So why isn't the longest day not the hottest day of the summer? In fact, look across the United States here. The warmest day in summer in Pennsylvania, we're in that little yellow to orange shade, so it's about mid-July. Some places the warmest day doesn't come until mid-August, like down in Texas and over in Southern California along the coast. Not only that, why isn't the longest day not the hottest day of the summer? Why isn't the hottest part of the day at noon? If the sun's right overhead at noon, it should be the hottest part of the day. Why does it wait till 3, 4 o'clock in the afternoon? Well, take a look at this graph. On the left, we have midnight. We'll have sunrise at 6 o'clock, and then we'll have sunset at 6 o'clock in the afternoon. Let's go ahead and take a look at what's happening overnight. There's no sun in the sky, but the sun has spent all day heating the Earth. So the Earth is giving off heat and energy that it received all day from the sun. Look at the blue line right here and notice that it is falling down. It is getting lower. And that the temperature, this red line here, is getting lower with it. The air is heated by the ground. As the ground gives off less energy, the air is going to get colder. Now at 6 o'clock, our sun begins to rise. As it rises, it's providing the Earth with heat and energy. So the blue line starts to go up again, and the temperature starts to rise as well. At noon, we're getting the most direct rays from the sun at that part of the day. So the Earth is continuing to bake and is continuing to increase the temperature of the air. But as we go into the afternoon, even though the sun is becoming less intense, the overall effect is the Earth is still absorbing heat at that point. Therefore, the Earth gets hotter and the air gets hotter. It's around 3, 4 o'clock in the afternoon that the amount of heat being given off by the Earth ends up being a little bit more than what it's getting from the sun. And that's where the temperature starts to cool. The Earth starts to cool, therefore the air continues to cool. And of course, once the sun goes down, the Earth is radiating its heat into space during the night, which is making the temperature decrease. So the hottest part of the day is going to lag a little bit behind when we get the most direct rays. Now this also answers the question, why is July hotter than June? Same thing, just replace the dates at the bottom with months, and you get the same answer. The most direct rays come on June 21st, and it's usually mid-July before the balance of the heat that the Earth is absorbed starts to cool off itself. That leaves us with just one more thing, a dumb and useless fact. Our second one. Which season is the longest season in the United States? You would think that they're all the same, but they're not, because the Earth goes different speeds around the sun. Our longest season is summer. As we approach the winter solstice, which is when we're closest to the sun's gravity is speeding us up as we round the corner of the sun there. So we actually spend about, in total, 3 fewer days in the winter, with 3 longer days in the summer. Again, dumb and useless fact. So that's why we have seasons. It has nothing to do with how close we are to the sun. It has to do with the tilt and where the direct rays fall.